Good morning, my dear students. Welcome back to the session. In our last class, we have discussed about the electric field due to an electric dipole along its equatorial line. Today, we are going to see the torque experienced by a dipole in a uniform electric field. Consider a dipole of charge plus q and minus q with separation of 2a kept in an uniform electric field. Let us see the diagram. Consider the charge minus q, which is placed at A, plus q, which is placed at B. The distances between the two charges are 2a. These two charges are act as an electric dipole. These two charges are kept in an uniform electric field. In this uniform electric field, the magnitude of electric field is constant at everywhere. Here, the electric lines of forces are parallel to each other. The force produced by the plus q charge is equal to plus qe. The force produced due to the minus q charge is equal to minus of q into e. First of all, we are going to see the net force. The net force is equal to sum of the individual forces. The force due to the minus q charge is equal to minus q into E plus the force due to the plus q charge is equal to plus q into E. Henceforth, the net force produced by the electric dipole is equal to 0. This electric dipole is with an angle theta with respect to the uniform electric field. Hence, there is no linear motion, but there is equal and opposite forces which creates a torque on the dipole due to which it starts rotating in the uniform electric field, and the torque is given by here the net force is equal to 0. Henceforth, there is no linear motion. It produces a torque. So the torque tau is nothing but the force into perpendicular distance. Here force means any one of the force F into perpendicular distance. Let us see the right angle triangle ABC. The value of sin theta is equal to opposite by hypotenuse BC divided by AB. Therefore the sin theta is equal to BC divided by AB. Here A to B is separated by a distance of 2a. So the sin theta is equal to BC divided by 2a. Therefore the value of B to C is equal to 2a sin theta. Substitute the value of 2a sin theta in the main equation. We can get the value of torque tau is equal to Q into electric field vector into 2a sin theta. Rearrange the equation. The value of q into 2a is nothing but the dipole moment. So we can rewrite this equation q into 2a, which is equal to p. Therefore value of torque tau is equal to Pe sin theta. The value of a vector cross b vector is equal to ab sin theta n cap. So in the vector formation, the value of Pe sin theta can be rewrite by chow vector is equal to P vector into E vector. Electric potential energy of an electric dipole in an uniform electric field. The electric potential energy of a dipole in an electrostatic field is the work done in rotating the dipole to the desired position in the electric field. When an electric dipole of dipole moment P is at an angle theta with respect to the electric field E. The torque on the dipole, we know that we are familiar with the torque experienced by the dipole in an uniform electric field tau is equal to Pe sin theta. Now we are going to rotating the dipole through the angle d theta. Therefore, the work done in rotating the dipole through an angle d theta, we must have to do work to rotate the electric dipole to the desired position. The changing work done dW is equal to torque into desired angle t theta. Substitute the value of tau here. The value of dW is equal to Pe sin theta into d theta. The total work done in rotating the dipole through an angle theta. Now we are going to find out the net work done. Net work done is equal to integration of dW. Substitute the value in the above equation. We can get W is equal to integration of Pe sin theta into d theta. Here the value of P, which is electric dipole moment, and the value of E, electric field, both are constant, which cannot be integrated. So we can take into the outside of the integration. We can get W is equal to Pe into integration of sin theta into d theta. Integration of sin theta to d theta minus of cos theta. Therefore, the net work done is equal to minus of Pe cos theta. This work done is the potential energy of the dipole, which is given by U is equal to minus of Pe cos theta. We will see the remaining topics in our next class.